Okay, so we're going to start by reviewing horizontal and vertical translations. So as a reminder, if we're dealing with our function, then we'll have x minus h on the inside, that's what's affecting the x, and then plus k on the outside. So again, this is our horizontal translation, so that would be shifting left, right, up, down, and then we know that this is our vertical translation. That's going to be shifting our graph up, down, left, or right. And so if h is positive, so we have x minus h, we're going to be shifting to the right. If h is negative, so we have x plus h, we're shifting left. And then if I have a plus k, we're going to be shifting up, and a minus k, we will be shifting down. And so when we do translations, these are always going to be the last transformation we do. So the first things we always want to look for are there any reflections? And so when we look for reflections, we can do them in two ways. We can have a horizontal or a vertical reflection. And just like it sounds, it's going to reflect the graph. It's going to reflect our entire graph across the x or y axes. So the first one we'll look at is a vertical reflection. And so just like it sounds like, it's vertically, so it's going to be reflecting it over the x-axis. And this will affect the y value. So this will affect all of our y values as we go through this. So when we see this, we'll have our function, it will have a negative on the outside because p of x is going to give us that y value, and so it's going to become negative. So let's do an example. So let's look at our function when we have negative x squared. So if it helps you, go ahead and graph your t-chart and then graph your function, your parent function, which we can identify our parent function as just x squared. So take a second and graph that, and then we'll come together and see how it reflects. Okay, so we see our parent function has been graphed here. And so when I'm looking at the negative, we know that what's happening is that all of the y values, instead of becoming positive, are now going to become negative. So at 0, we're going to stay at 0. Instead of being at a positive 1 for y, we're now at negative 1. Instead of being at a positive 4, now we're at negative 4. And the same thing's going to happen on the other side as well. And so we can see that our graph has the same shape as our parent function. However, it's now been reflected over the x-axis. And so when we talk about our domain and range, we're still going to be looking at all of our x values for domain. So we're still negative infinity to infinity. But our range here is different because now we're starting at negative infinity and we're going up to and including 0. So the range is now the opposite of what it was ahead of time. Okay, so if we're looking at any kind of graph, one thing we want to keep in mind is that anytime you see any other shifts, horizontal or vertical, you want to reflect first. So if you have reflections and shifts, you want to reflect first and then shift. So an example of what that might look like is, we'll do it with a cubic, something a little bit different. So if I have my function g of x is equal to negative x plus 1 cubed minus 2. So what we're going to look at first is what's happening. So we have a reflection across our x-axis. It's that vertical reflection. That's what this negative is doing. It's reflecting. And then we have a shift to the left 1 unit, and again, it's not one box, it's 1 unit. So however many boxes it takes to get to units, to 1 unit. And then we're going to shift down 2. So this positive 1 is what's shifting it left 1. And then we can also look at this negative 2 is what's shifting it down 2. So why don't you take a second? We know that our parent function here is x cubed. So take a second and graph that parent function. Okay, so I have my parent function graphed here with x's for the parent of x cubed. Then you can see that we're going to reflect first. So we always want to make sure that we reflect first and then shift. So I'm going to take all of these values and reflect them over the x-axis. So I'm going to do that in purple. So if I'm at positive 8 here, I'm going to go all the way down here to negative 8. If I'm at positive 1, I go to negative 1, 0 stays the same, and then these will just reflect up. And so one thing I do want to note is that we are reflecting up here. We're not necessarily reflecting across the y-axis. So be very careful that you're reflecting across the appropriate axis. So now that I've reflected, now I can shift. So first I'm going to shift everything left 1 unit. So all of these values are going to shift. And then the last thing that happens, and I'll do this in turquoise, is that we're shifting down 2. So I'm going to move all of these green points down 2. I need to extend my axis here to negative 10. And so now I can just connect to the best of my ability these points. Sometimes it can be tricky if you're not using like perfect graph paper. So something like this. More or less like that. And so when I look at my domain, I notice that I'm using all x values, and the same thing is true with my range. We're reaching all y values and all x values for this graph. Okay, so that's vertical reflection. So reflecting across the x-axis, and that affects the y values. So then the next one we'll talk about are horizontal reflections, and so it's just the opposite. Instead of reflecting across the x-axis, we're reflecting across the y-axis. And so these will obviously affect the x values. And so the difference here is that instead of having it on the outside of the parent function, it's now inside with the x. And so when we do this first example, we're going to use a square root. And so it can look a little funny because we know typically that we can't take the square root of a negative, and that is true. However, when it talks about graphing these functions, we are going to involve this negative here. And what happens is that when I plug in negative values for x, I have a negative times a negative, which makes it positive, so I can in fact take that square root. So this is going to reflect across the y-axis, and it's going to make all of our x values negative. So we know that our parent function here is the square root of x. So why don't you take a second and graph the parent function. Okay, so I see here that I have my parent function graphed at 0, 0, 1, 1, 4, 2, and 9, 3. So when I look about reflecting across the y-axis, the x values here that were positive are now going to become negative. And so 0 will stay the same. Now I have one at negative 1, 1, negative 4, 2, and negative 9, 3. And so I'll connect those turquoise points together, and I get my lovely looking square root graph. And now remember, it doesn't continue in the right side, because if I do take a positive value over here, like 4, if I substitute 4 in for x, I get the square root of negative 4, which I can't do, it's imaginary. which is why we're only using the negative values on this side. So our domain and range are affected by this. So the domain starts at negative infinity and goes up to 0. And then our range is the same. It starts at 0 though, and then continues up to infinity because we're just constantly getting larger as we go up. So again, to kind of think about one that might have both reflections and shifts in it, always reflect first and then shift. So another example we'll look at has a reflection and some shifts. So if I have g of x, that's equal to the square root of negative x plus 3, and then minus 1. And a really important thing to note here is that we're always going to reflect first. We talked about that. And then we also want to make sure that we factor out anything that's in front of x. So I want to make sure to factor out this negative first. So factor out the negative inside the square root because that's going to show you our shift. So what I mean by that is we're going to look at this now as g of x is equal to the square root of negative x minus 3 and then a minus 1. So it only affects what's underneath the square root, doesn't affect the negative 1 at all, and now that we factored it out, I can actually see what's happening. So we not only are going to be reflecting over the y-axis, we're actually going to be shifting this whole graph right 3 units, and then we are shifting the graph down 1. And so these are the order that I'm going to do them. Again, we always want to reflect first, and the shifts you can actually do together if you want. But the important thing to remember is that we had to factor out that negative. And so this one became negative as well. So again, we know our parent function is the square root of x. So take a second and graph that. Okay, so we have our parent function graphed here. And so now I'm going to first reflect over the y-axis. I'll do that in purple. So all of these points here on the right are now going to reflect, and they're now going to go over here onto the left. So I see in purple I have my nice reflected curve on that side. Then I'm going to shift all of these points to the right 3 units. 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then lastly, we're going to shift this whole graph down 1 unit. So I'm just going to shift those green points down 1 unit. And again, this thing doesn't continue in that right direction because remember it started right here at 0, 0. So it shifted to the right 3 and down 1. That's where it's going to start. And so our graph will look something like that. And that's your graph. So when I look at my domain, I can see that my domain goes from negative infinity up to 3. And my range starts at negative 1 and goes up to infinity. I really like using square root graphs for vertical and horizontal reflections. I feel like it really shows the differences in the two of them and what they do. And so when we do, now we're going to do vertical and horizontal reflections together, you'll kind of see how they're different. So when we mix vertical and horizontal reflections, we'll see what happens with a square root graph. It just shows a little bit easier. So this is going to reflect across both axes. And so to do that, we'll see that our parent function, our function will be equal to a negative of the parent, which has a negative x on the inside. So the one on the outside is your vertical reflection, and the one on the inside is your horizontal reflection. So let's start with an example of a square root, and we'll just do a negative square root of negative x. So let's just see what's happening. We know that our parent function is the square root of x, so take a second and graph that. Okay, so we know that two things are happening. We have two negatives here, and so the first one on the outside, we're going to be reflecting across the x-axis, and then we're also going to reflect across the y-axis. And so you can do them both at the same time, or you can do them individually. I'm just going to start with the first one and I'll break them apart. So when I reflect over the x-axis, all of these points are now going to become negative, but the x's are going to remain positive. So everything just gets reflected right over that x-axis. So now we're looking at the purple ones. And if you turn your paper, you'll actually see that that looks like a quadratic. It's just along a different axis. And that makes sense. And then the last piece would be reflecting over the y-axis. So instead of keeping the x's positive, now we're keeping the x's to be negative. And so they get reflected directly across that y-axis. And so I can move them over as if there was a mirror here on the y-axis. And so this is my final curve. It starts at 0, 0, and it continues on in this direction forever. And so my domain would start at negative infinity and go to 0, and it includes 0 because we're right there, and our range is the same from negative infinity to 0 because we're starting very negative and then moving up to 0 and including 0. The order doesn't matter on which reflection you do first. So you could have reflected across the y-axis and then over the x-axis, but as long as you reflect before you shift, that's all that's important. And so I'll just write that here, that reflection order doesn't matter. We just need to reflect first, then shift. Okay, so our last example that we'll do today is one that involves both reflections and some horizontal shifts. And so for the example, I'll use another square root just because it does work really well to kind of show you what's happening. So why don't you take a second and see what you can do if you can get started with the parent function, etc., what's going on, which direction we're shifting, etc., and then we'll go from there. Okay, so ideally you remembered to factor out this negative first. This negative, remember, factored out is what's being reflected over the y-axis. It's that horizontal reflection, which causes this to become positive. And so we're actually shifting this graph to the left 1 unit because we have to remember to factor out the negative. Everything else remains the same. So the first thing I'm going to do is take my parent function and reflect it over the x-axis. And so I have a graph that looks like that. And then I will reflect over the y-axis, so everything will be equidistant away from the y-axis. And so it'll be here and here. So you can see the green right there, that's going to be our reflected over x and y axes. Now we're going to shift it to the left 1 unit. So everything moves left. Skip this one. And then lastly, we're going to shift everything up 2 units. So I'll take the turquoise ones and move them up 2. So 1, 2. And so this is going to be my final graph. So it looks something like that. And again, it starts or stops right here because that's the point that moved from 0, 0. So when we look at our domain, we're going from negative infinity up to negative 1. And then our range, we're from negative infinity up to 2. because that's as high as we go. So 2 important takeaways: reflect, then shift. For horizontal reflections, always make sure to factor out that reflection so that you can see which way we shift. Okay, and that's it.